अपने ड्राइव पे, ठीक है। थोड़ा सा कॉम्प्लिकेटेड प्रोसीजर है, सो अंडरस्टैंड प्रॉपरली, सो दैट्स व्हाई आई एम पुटिंग ऑन रिकॉर्डिंग। Okay, so let's see. Yeah. So first of all, whenever you click on that, it will just ask for the workspace where you want to create your folder वगैरह. So just select the path. Okay. Let's suppose I will create something new folder in embedded practice. Let's suppose the name is, yeah, here. Okay. I will create new folder here. Second time. Just then let's suppose I will just name it as, um, let's suppose ARM. Okay. So I just named it as ARM. Say okay. Uh, Select that folder properly. It's still showing a new folder. And this, let's suppose R. Okay. I'm selecting that folder. So once you select the folder, say okay. It will take some time to open. And before that, just ensure once you install that, you have to just ensure one more thing. You have to go in a C drive, right? Then in C drive, you will be having this TI folder. Okay, open it up. After that, now once you install that TIVA C launchpad, you will get this TIVA C series, TIVAware C series करके. Okay, this folder will be there in a C. So you open this one. In this, just a minute, let me just, yeah, TIVA C series. In this there is something which is called the INC include. Okay, so here are the header files. Now what you have to do is that you have to just copy this particular header file. Okay, just copy this TM4C123GH6PM, which is our device. So this header file you have to copy and you have to paste in another path. So that path is once again go in C drive TI. Now that header file you have to just paste it in this Code Composer Studio. Okay, so you have to just go here in Code Composer Studio. In that tools, go in compiler. In a compiler, go in this TI CGT ARM 5.2.5. In this you will have this include folder, and यहाँ पे you have to just paste that file. Now I have already copied. Yeah, so this file is already copied. There's a TM4C123GS6PM. Its size is 696 KB. So this header file is required for programming our device. Correct. So once again I'm telling you what you have to do is that in a C drive go to the TA. From this TIVA, once you install the TIVAware C series, so it will just add that all the required header file. So in this include, at the last you will be having this file. So this is what you have to copy and then you have to paste it in CCS. Then go in CCS, tools, compiler, then this TI CGT ARM 5.2.5, and in this include. So in this folder you have to just copy that file. Fine. Yeah, it is there. This file. Okay. Then once you copy that, yeah. So this is the page which is opened by the CCS. You may say the dashboard for it. Then what you have to do is, let's see, so the procedure is important. It's somewhat rules are complicated. Then go in a project, new CCS project. Come on. A second. Yeah. So it will just open window like this. Then after that, what you have to do is that you have to first select this target device, just watch this procedure properly. Getting, you have to go in a target, then just write down your target name, that is a TM4C123GH6PM. So that is our device. So you will see over here, you have to select this one. Okay. After that, you have to just do the change in a connection. In a connection, you have to select this Stellaris. Okay. So this is also the driver which you have to install. Then you have to give that project name. Okay. Let's suppose project name also I will just give ARM only. Getting it? Okay. You can just give any project name. Then let's suppose I'm giving ARM. Okay. After that, this compiler version, this is going to be 5.2.5 only, because here we have just added that, just keep it by default, and here it will just create empty project with the main.c. Okay, so keep this setting by default, say finish. So once you say finish, it will just open a workspace. Just let it settle. Okay, then afterward what you have to do is that, so here actually you have to write a code, but before that some settings you have to do. So here you can see that your project ARM which you have created, right click on that, right click, go to the properties, you have to set true path in this, go to the properties, then in ARM compiler you have to go in include option. In ARM compiler you have to go in include option. Okay, then यहाँ पे in this add directory to the include search path, you have to add one directory, that is I will just show you. So then you have to just go on this particular add button. Fine. So go on that add button, then you have to just browse for that file, that is a TIVA C series. Okay, then go to the C drive, in this C drive TI folder. Okay, in TI TIVA C series. Fine, and this is the folder which you have to select. So just select this particular folder and say OK. Fine. So this is the directory which you have to add. That's it. It will just add it. Fine. So what you have to do in properties, just go in ARM compiler, inside this include option. So here you have to add that directory. Fine. Once you add that, then once again you have to go in ARM linker. One more thing is the ARM linker. Getting, in that ARM linker you have to go in a file search path. File search path here. So you have to just add one driver library. So file search path here, just click on this add. Fine. Then once again you have to browse. Go to the TI folder in a C drive. TI. Then once again in TIVA C. In a TIVA there is a driver library. In a CCS, in debug, this particular library, that driver library. This is what you have to include. Fine. Then say open and OK. Fine. So you will just add this particular library. So these are the two settings which you have to do in a project, and then say OK. Fine. It will take some time. Yeah, fine. So once again, what you have done, simple right click on this one, go in properties. In this ARM compiler, in the include option, you have to add that directory. And in ARM linker, in a file search path, you have to add that driver library. Fine. So once you're done with this one, now you are ready to code. Okay. Now here in this space, you have to just code. Now for the time being, I will just copy paste the code which I am having over here. I will just explaining what that code is. It's simple. So I'm just copying it. Okay. I just copied the code. Zoom और I get. सेव करो इसको. I will just explain the code on Notepad itself, so it will be visible. Let's see what you have done is simple. So first of all, I included this library, include standard int.h and include tm4c123gh6pm.h. Just add it in this code because we have just kept in that folder. So that's why I just added in code. Then this is the program. Now first of all, what are we doing is simple. We have seen in Keel also. First of all, I'm just setting the system clock, and I hope you remember this particular value. Okay, but in TIVA, how do we access the register? It's just simple. Now we have to just say like this: so system clock main part, then underscore RCC, in that RCC, and underscore R. R means what? Register. Okay, so system clock underscore RCC underscore R. So this register which you want to access. Getting? Then in this I will just put this value. This is the value which you have explained last time. How do we get this one for the 40 megahertz? Getting? So this is the value which I'm adding to this one. Then afterward you have to just enable that uh, clock for the port F. So how do we do that? System clock RCGC GPIO register. Okay, and here I am just adding this system control RCGC GPIO R5. Now it will just enable that clock for the port F. Okay, now as we are using this code composer studio, we can just write that values by the name. Okay, how do we give this name? That I will just tell you later on. Getting it? Okay, so if I just type this one, it will just make that particular bit as a one. So it will just make that fifth bit of the register as a one, and it will just allow that pass that clock to the port number F. That clock will be enabled for the port F. Okay, then afterward, in the port F, we have to just enable this. We have to just make it digitally enable, and we have to just make its direction as the output. So how do we do that? So in the GPIO, we want to access that port F. In that we are having three register DN, direction, and data. So I will just digitally enable that, digital enable, then R. So this is how we write in Code Composer Studio. GPIO underscore, in GPIO we are going to the port F. In port F we want to access the DN. So this is the path you have to give. Okay, and DN underscore R. And so this register value we want to change. Now to enable that, what I'm doing is that I'm just enabling all the pins of port F as a digital enable. So I'm just writing here FFF. So last four pins 0, 1, 2, 3, 4, where actually our LED and everything is connected, I will just make it as digitally enabled. Likewise, we want to make that output as the we want to make the direction as the output. So once again, I will use another register that's a GPIO port F underscore DIR, that is for the direction, underscore R, that is for once again for the register. Okay, so or equal to, once again I will make it as a F. So if I write one, means what, that particular page will be acting as output. Okay, so what do we do? First of all, first set the system clock, then enable the clock for the port F, then make that port F as a digitally enable, then make that port F that particular pins as the output, and then we will write a program. So what are we doing over here? Nothing. We are just turning on that LEDs one by one, because so LEDs are connected at PF1, PF2, and PF3. These are the pins on which the LEDs are connected. Okay, so to make it on, will to pass the data to the particular pin, I'll be using GPIO port F data register. So in GPIO port F, we are going to use a data register, data underscore R, and to which I will just make that first PF1 as a one, then PF2 as a one, then PF3 as a one. So to make PF1 as a one to on that LED, I think it's a red LED. The value which I have to pass is 0x000002. So that first bit will be the one. Okay. After that, I'm just calling the delay. Now this is what the inbuilt delay. So I'm just using this underscore underscore delay underscore cycles 80,000 8 lakh. Okay. So this is what the delay I have given. This is the inbuilt function which I'm using. Then afterward, I'm just making that pin that LED off. So to make it off, you have to pass zero. Ready? So once again, in a data register, I'm passing a zero. So GPIO port F data register, I'm making it off. Okay. So I just on that LED which are connected to the port F1 first pin. Then I'm just giving the delay. I'm just making it on for some time, and uske baad I'm making it off. Okay. Once again, I'm calling a delay. Fine. Likewise, I will just on the another LED which is the PF2. So to on that LED which is connected to the PF2, we want to make the second bit as a one. So the value will be the 4. So once again, this particular 4 line, I'm just copy pasting again, and we are just changing the value, nothing else. Okay. So I'm just writing GPIO port F data register. Here I'm just making it 4. That's it. Then once again a delay. Then once again make it off, and once again a delay. Okay. And to make that last one register, last one LED N which is connected at last one LED as a on, which is connected at PF3. I'm passing the value to 008. That's it. Okay. So this is how this is the style in which we just write in Code Composer Studio. Fine. So this is the program which is written over here. Okay. After that, what you have to do is that just build the program by using this one build button. Let it build. Yeah, build finish. Good. You must just say see like this one. Finish building target and arm out. What are your project is that project name dot out. Okay. So you can confirm that yes your program is right. Okay. After that, now what you have to do is that you have to just press on this debug. Okay. Once you press on debug, it will just pass that code in your device also. You have to just press a debug. Okay. Yeah. So here you can see that memory map initialization complete. Okay, fine. So now your program is dumped into the TIVA launchpad. Now what you have to do is that I will just turn on my camera so that you can see. Now visible. Yeah. Now what you have to do is uh, just you have to press a reset button on a board, right? And once you press a reset button, you can just see that all the LEDs are blinking. I hope you can see. Can you see this one? Hello.
Yes, sir.
Okay. Okay. So this is how you have to code. Fine. Actually, let's suppose I will do some changes in a code. You have to just say terminate over here. I have just shared that how to use this code composer studio. That document also available. Let's suppose how to comment it out. I will just on only two LEDs. I will just delete this particular part. Okay. I will save it again. Debug it. Oh, sorry, build it. It's not debug. It's a build. Okay. And then once the build is finished, you have to just click on this one, debug. So it will write that file in your TIVA launchpad, but make sure that you have connected that kit. Fine. Once it is done, I hope my camera is on. Yeah. So अभी तो फिलहाल कुछ नहीं हो रहा है. So once I will press a reset button यहाँ पे, let it get clear image. Image clear नहीं हो रहा है. So if I press the reset, yeah, it is glowing. Now I just enable only two LEDs, blue and green. So red LED अभी glow नहीं हो रहा है. ठीक है. So this is how we will be performing experiment by using Code Composer Studio. I hope you have understood the procedure. Any doubt in the procedure? Now I will just stop recording so that this procedure will be available to you.